vertical shift, all those four. And the flow, you do transformations, must be at the same flow. Where the first one, you have to do horizontal shift, regardless of whatever the types of transformations, whatever transformations you need to use in order to solve the questions, the problems, you have to follow the flow. The first one is horizontal shift, and then goes to compress or stretch, and then goes to reflections, and then the last one goes to vertical shift. And for the process of transformations, even though we have four types of transformations, not necessary that the graph that we want to sketch must include all transformations. Some of them include only 3 transformations. Does not matter. Does not matter. The important is we follow the flow. For instance, given a function which we want to sketch is 3 to the power of 3 times 1 over 4 to the power of x minus 2 plus 1. Right. Sketch fx, the function of fx, by using transformation. We need to sketch by using transformations, which means that we need to sketch one by one. Seems like we do transformations. Each stage show at least 2 points. Okay. At least 2 points. And then determine the domain and range of the functions of fx. We need to determine domain and range of the functions of fx. We want to sketch the functions 3 times 1 over 4 power of x minus 2 plus 1. Right. When you see the function that we want to sketch, this function, what can we say? Which functions we need to start with? What types of functions? What types of functions we need to start with? What type of functions? We need to start with can you think what type of functions we need to start with?
Linear functions.
Linear function. Why linear functions?
Because x minus 2.
X minus 2 located here. Why we need to start with the linear functions? Yes, x minus 2, but x minus 2 located here. Not linear functions. What type of functions we need to start with?
Exponential.
Huh? We want to sketch this function. Remember that when we do transformations, we need to know the basic function, basic graph that we want to start. If we want to sketch square function, we need to start with the square function. If we want to sketch what square root functions, we have to start with the square root function. Exponential functions. And when we talk about exponential function, we have two types of exponential function. Okay, we start with the exponential function. Which exponential functions we need to start? Which exponential functions we need to start? Yes, we need to do exponential functions. But what exponential functions we need to start with?
Oh, x.
Huh?
Oh, x ya.
Huh?
Oh, x.
For x, which type of exponential function? We have two types of exponential function. Which type of exponential functions we need to start with? Remember that exponential function, this type of graph, or another one, this type of graph. Which one we start with? Which one we start with? Left or right? Right. Why we start with right one?
Positive, sir.
It is less than 0.
Positive, It's sir. between 0 and 1.
Between 0 and 1. So these types of graph. So 1 point, remember, because each stage show 2 points. 1 point is points of 0, 1. And another points. Another points.
1, 1, sir.
1, 1. No, it's not 1, 1. We don't have point 1, 1 here. So what is the functions? We have to look at the function first. What is the function? The first functions. The first ever functions we want to start with. The functions of? The functions of what? Huh?
1/4 to the power of x.
1/4 to the power of x, right? And now if you imagine that the value of x is 0, the value of y is what?
1, sir.
1. Okay. If the value of x is 1, if the value of x is 1,
Y equal to 1/4.
so another point is 1, 1/4. How we do obtain 1/4? Because we substitute here. We substitute in this is the graph of this fx. When we say that x is 1, what is the value of y? You substitute 1 here, which is about what is 1/4. So 1 point is, another point is 1 for x and 1/4 for y. And also another point is when we substitute x with 0, we will get 1/4 power of 0, which is 1. Understand why we get those 2 points? These points already given. So we know that the crossings of y exist where? At the point of 0, 1. You get it? Any question you may ask? For the process of the what we call teaching and learning. I say, I tell you, you ask. And you unclear, tell, you ask. Make at that our class is 2 ways communications. Provided that you do not know, but if you know, that's not matter. If you unclear, so I say I will explain. How do we get it?
Sir,
Yes.
where we choose graph exponential, but between 0 and 1.
Yes.
We look at 1/4.
We look at 1/4.
How we want to know? We use the
We look at here. We look here. We look at the value here. Some of the question, maybe the value here is greater than 1. So we choose another graph. But in this case, this value. Let's we choose with this graph. And how to know 2 points? 1, you just substitute. I hope that you know that how to get those 2 points. Hopefully, very well. Hopefully, very, very hope. So this is what we call basic graph. We don't do anything yet. No process of transformations start yet. Every times, remember that every times when we want to make transformations, we have to start with the basic graph. So basic graph, we have to determine which one is supposed to be our basic graph. Since we want to sketch this function, this is exponential functions. When we look here, it's exponential. So, like or not, our basic graph must be exponential. So we don't need to think about linear or quadratic or square root function. No. And then we start the process of transformations. First one. Before that, sorry. Asymptotes, when I explained last time, asymptote is here. And this is horizontal asymptotes. Right. Horizontal asymptote is this line. X exists, or we say that line y equal to 0. And not just y equal to 0, because y equal to 0 can be here, can be here, can be. We say the line y equal to this one line become our horizontal asymptotes. Right. And now we start the process of transformations. Which one we have to do first?
Horizontal shift.
Horizontal shift. Shift to where?
To the right.
Shift to the right. Shift right. How many units?
2.
2 units. Therefore, our graph, the shape same. The shape same. X, Y, and our function now, we want to sketch the function. What become our function now? The new functions.
1/4
1/4
to the power of
x
minus 2.
x minus 2. So the points of 0, 1 will go to the points of
2, 1.
2, 1. So let's say 2, 1. Points of 1/4 will go to the points
3, 1/4.
3, 1/4. The locations of the points may be not exactly because we just sketch the graph, but the important is we show that the point is here. So we know. So our 2 points before is 0, 1, and 1/4 become 2, 1, 3, 1/4. Then what? Which one? Then
Vertical stretch.
okay, vertical stretch. Okay, when we say vertical stretch, vertical is go up, right? Stretch. So which coordinates change? Which coordinates will be changed?
Y.
So each y coordinate, we have to multiply by what?
3.
3. So the graph become like this. The shape same. The shape still same. X, Y. Points of 2, 1 will go to the points of
2, 3.
2, 3. Let's say 2, 3. Points of 3, 1/4 will go to the points
3, 3/4.
3, 3/4. 3, 3/4. And our new function, what is the functions of new function?
3, 1/4.
3 times 1/4 to the power of x minus 2. Exactly same with the transformation before. But we still have one more transformations because we want to sketch this. So one more transformations is what?
Vertical shifting.
Vertical shift. Shift to what?
To the upward.
Shift upward. How many units?
1.
1 unit. Therefore, our graph, the last graph, in fact, is going to be shape same. X, Y. Points of 2, 3 will go to the points of
2, 4.
2, 4. Let's see. 2, 4. Let's see. Points of 3, 3/4 will go to the points
7/4.
3, 3, 3, 7/4. And what is our function now? What is our functions now?
3 multiplied by
3
1/4
multiplied by
to the
1/4
power
to the power of x minus 2 and then plus 1. Which is this one. And remember that we have asymptotes, right? Asymptotes is here, and then still here, still here. But now we shift upward, which means that asymptotes also shift it up. So asymptotes, we shift it up. So our new horizontal asymptote, this is horizontal asymptotes. Line of what? Line of what?
Y equals to 1.
Y equal to 1. You look that asymptote is not stick at one place. It will go wherever graph goes. In this case, asymptote stick from here to here because the graph still there. Don't go anywhere. Because all the transformations before is involving of the movement to up or down. But for the case of number 4, yes, movement from to up. So asymptotes also will go up. If the case that we have to move down, we may have the case to have to move down. Asymptotes also move down. Any questions so far? Transformations, we have 1, 2, 3. Only 3 transformations. Even though we have 4 types of transformations, it does mean that we don't have one of transformation. Which transformation is not involved here?
Reflect.
Reflections. We don't have reflections. We know that it won't have reflections straight. When we see the function, we know that no reflection. When we don't have negative. When we don't have negative here, when we don't have negative here. Because reflections play with the negative. If negative here, reflections about what? Y exists. If negative here, reflections about X exists. Reflections only about X, about Y exists. So for this case, we have no case of reflections, so that we have only 3 types of transformations. Three types of transformations. Right? Last asymptotes appear here also, only that we do not sketch. We have asymptote, only we sketch on the final graph. But still there. Question.
So,
Yes.
still don't understand how to find horizontal asymptote.
Okay, horizontal asymptotes. If you remember the last class on Tuesday, horizontal asymptote is here. So is that from here to here? Is that change of horizontal asymptotes? No, no change. Horizontal asymptote is like that. When we sketch the graph will not go past the horizontal asymptotes. So where the graph do not pass this point, this line, if you sketch further, because this graph is not just here, just sketch further, you sketch further. So the graph not pass this line. Then the last one, when we shift up to unit, 1 unit, graph up asymptotes. Originate is here. Go up 1 unit. And remember that when you sketch this graph will never pass this line. You try. How to know how to sketch? You put the value of X, what the value of Y. Put the value of X, what the value of Y. And you try. You will get that our graph, if we sketch more here, will not pass this. Just go approach, but not pass. This line become like this, right? For example, if you sketch this graph will go approach. Just approach. Approach. But never pass that line. Just approach. can go approach, can go close, but cannot touch. Ah. That is the concept of asymptotes, right? Then the last part is to determine what is the domain and range of the function. What is our function now? This is our function now. And what is the domain and range of this function? What is the domain? What is the domain of this function?
Negative infinity to infinity.
Minus infinity to infinity, because it's come from, we don't know where, minus infinity. And finish where? We don't know. And the domain, range, range.
4 until infinity.
4,
No.
huh?
Uh,
Why 4?
1.
1 until infinity. 1 because this graph will not go past 1. So 1 is not including. 1 until infinity. 1 not including. And that's the range. The domain is minus infinity until infinity. Right. The most important is follow the flow. I said that because some of the paper that I look for OBT, we have the questions of transformations. Normally, majority of the students do not follow the flow. When do not follow the flow, definitely wrong. You end up with something wrong. It's pity. It's pity because you write a transformation, right? But it's wrong. Wrong. Even some of the students, even basic graph wrong. Basic graph, the graph that you want to start with. On that one pass, right? Later on, you do not make the same mistake again. Then that one, I don't know which group, right? That I looked so far, right? Right. So we take 5 minutes break. Right. Welcome back. Are you ready to continue? Okay. Let's say we change the functions now. The functions of e to the power of x plus 2 minus 3. Sketch the functions of fx, and at each stage show where the 2 points goes, and the last one is to determine domain and range of the functions of fx. Now, this is the functions of fx, and this one we would like to create or to sketch. Okay, which type of functions we need to start with?
Exponential function.
Exponential functions. Which one? Because exponential function, we have two shapes of the graph. Which one? Is it same like before? Or different from before?
Same like before.
Same like before? You mean like this? It is.
No,
Why
same
you
positive
say
graph.
same like this? Why you say it is same like this if you say this? Same like before. Why? Why do you say, if you say same like before, same like this? Why? Why do you say same like this?
Sir, can I ask
Huh?
what the function I cannot see?
Sorry?
What the function?
We not see the power top of E.
X. Here. You mean
Yes, sir.
e to the power of x plus 2?
E.
E to the power of x plus 2. You cannot see that.
Cannot see, sir.
Huh?
Alright.
Right. Which one function we start with? This graph.
Positive graph, sir.
Positive graph. You mean
Yes, still positive one.
this one? Yes. We start with the positive graph. Why we start with this graph? Why? Why we need to start with this graph instead of this graph?
E more than one.
Because E, as I said before, E has a value between 2 and 3. When you look E is located between 2 and 3. You can see from your books the value of E. E is approximately 2.718. Or maybe you get E when you study physics. E. So points here is points crossing of X or axis. Points. Point 1.
0, 1.
0, 1. And another points we choose is the points of 1, 1, 1.
E.
E. And the function is the functions of what is the functions? The basic function. This is basic graph.
E power of x.
E to the power of x. That's why 1 E, because when we substitute x with 1, what is the value of fx or y? Y is what E? To know another point, the easiest way, you just substitute the value of x is 2, e to the power of 2. We choose that x is 1 and x is 0. When x is 0, e to the power of 0, which is 1. Everything's power of 0 must be equal to 1. You get it? Why we choose this? I hope that you know that why we choose these functions as our basic functions. So the locations of asymptote is here. This line. We do not write. We do not draw yet. We will draw later. Okay. Then goes to transformations. Then we start off transformations. What? What transformations?
Shift to the left.
Shift to
To
left.
the left. By 2.
Shift left 2 units. So x, y, still crossing here, but points of 0, 1 will go to the points of what? This point. We want to know, we want to see the movement of those 2 points. Because if we talk about shape, it's going to be same shape. But we want to know the points. So point 0, 1 will go to which point?
To 1. And
0, negative 1.
negative.
Because of the negative for x is here minus 2, 1.
1.
Minus 2 because we shift left 2 units. So now it's going to be minus 2, 1. Points of 1e will go to the points
Minus 1e.
again minus for the negative. Remember, minus of negative must be here. Minus of negative. Minus 1e. Those 2 points now. So definitely crossings of y exist at no more x 0, 1. No more at 0, 1. But does not matter. We do not interested to find what is the crossings of y axis. We want to find where those 2 points goes to. And what is our new function? What is our new functions?
E the power of x plus 2.
That is our new functions. E to the power of x plus 2. Then, what we have? Then, what we transform this graph? We want to sketch this.
Vertical shift.
Okay, vertical shift. Shift to where?
Downward.
Down.
Shift down. How many units?
3 unit.
3 units. Therefore, our graph will become points of -2. 1 will go to the points. Sorry. We go to the points.
-2, -2.
-2, -2. Let's say here. Minus for both. For x minus, for y also minus. Let's say here. -2, -2, 1 points. Points of -1, E will go to the points.
-1 E -3.
-1 E -3. Let's say here. Why I substitute here? Why I say that the point is here? Can you see it? Why I say the point is here? To this point is here. -1. What? 3 minus E, right?
E -3.
E -3, E -3, sorry. E -3. Why? Why here? We don't know the locations. But I put it here. Why?
Because E is smaller than 3.
Because E is smaller than 3. What is the value of E? Is it 2.7 something? So it's going to be negative. So the graph become this. And what is the functions now? What is the functions now?
E power of x plus 2 minus 3.
And what happened to our asymptotes? You see, asymptotes is here and here. Then see, I said before, when graph goes down how many units?
3 units.
Therefore, asymptotes also goes down 3 units. So we have new line here to be our horizontal asymptotes. Horizontal asymptotes. Line y equal to what?
-3.
-3. Now, horizontal asymptotes now change because of the movements. Go down. The first examples, that's the first half, go up. Now go down. That's not matter. So horizontal asymptote is like that. Graph goes up, goes up. Graph goes down, goes down. It follows. Just follow. It's like tail. Tail. When body goes in front, tail go in front. When body goes back, what? The body, tail go back. Or have you ever seen that only body goes and tail stays there? When we talk about cow or tiger, right? Any questions so far? Right. So if you look at these transformations, it's more easier compared with the previous one. Why? Why? Why you say much more easier compared with the previous one? Why?
Because there's no need to reflect and compress or stretch. So,
Okay, because it's involved of only two transformations. No compressed stretch, no reflection. So when we talk about transformations, not necessary that our transformations must involve all of them. As we look at the example before and example now, example before only 3 transformations, example now at 2 transformations. Maybe in the questions in the examinations or quiz later, this question for OBT, for transformations, maybe these are only examples to show you the movements. Why become like this? Okay, the last part, determine the domain and range. So what is the domain? What is the domain?
negative infinity to infinity, sir?
Yes. Domain is minus infinity to infinity always. When we talk about exponential function, always from minus infinity to infinity, the domain. Only range is different. What is the range now?
-3 to infinity.
Yes, minus 3 to infinity. Because it starts from here. And remember that minus 3 must exclude. Minus 3, infinity, exclude. Any questions? Let's see. We have another functions. Two e to the power of 2 minus x, and then plus 1. Sketch the function.
Sir, we not see the equation there.
Okay, see now. 2e
Clear, sir.
to the power of 2 minus x, then plus 1. The first one, which graph we need to start with? Always the first one is the basic function. Which graph we can write as our basic function?
Same as previous, sir.
Same as the previous one. X, Y. Point here is point 1, 0. It's the same as previous. Sorry. This. Points here is points 0, 1, and another point is 1e. The function is the functions of e to the power of x. That's the basic functions. Before we go to this, okay, then we start off the transformations. The first one,
Shift to the left.
Shift to the left. How many units?
Two.
Unit. So the functions now, we shift to the left. So let's say x. Right, we shift to the left. So points 0, 1, we'll go to the points.
Negative 2, 1.
Negative 2, 1. Negative 2, 1. Negative 2 for x and also 1 for y. So it's like that. It's like that. Minus 2, 1. Minus 2, 1. The point, the original point is 0, 1. Points 1e. Will go to what points?
Minus 1e.
Minus 1, minus for the negative, for x. Minus 1, e. Definitely the new place of the crossing of y-axis, but we don't illustrate this place of crossing y-axis, except that question asks. If the question what is the place of the crossing y-axis, you have yet to search. Otherwise, you need to search. And what is our new function now? What is our new function?
E to the power 2 plus x.
2 plus
Plus
x or x plus 2. Same. 2 plus x or x plus 2, same. Then, hopefully you can continue from here. Remember that our function 2e to the power of 2 minus x plus 1 can also be written as 2e minus x plus 2. Same. 2 minus x, same as minus x plus 2. So we, in this stage, we make x plus 2. We make x plus 2. We at this stage. So we have several steps more to go. I hope you can finish. And then at the end, you find the domain and also the range. Of the functions. That's transformation of exponential functions. So remember that transformation of exponential functions, same like transformation of functions before. Only before we not deal with the exponential function, we only deal with the square functions. We only deal with the reciprocal functions. We only deal with the square root functions, cubic functions, cube root functions. But now we deal with exponential functions. So all kind of transformation must be for exponential function. And shape of the graph for exponential function, only two shapes. Which one we want to choose, either left or right, depends on the value of A. Remember that when you start study of exponential function last Tuesday, you get it? So,
Sir,
yes,
I think the second graph is wrong, sir. It's supposed to be x minus 2.
supposed to be x minus 2.
Yes, because later we be negative, we get 2 minus x.
You mean this one?
Yeah.
Correct?
Does it?
Correct. X plus 2.
Doesn't that mean it's supposed to be x minus 2?
Why
Because
x minus
we-
2? Why x minus 2? Is it 2 minus x?
Yeah, because after we negative, we get 2 minus x, right?
No, you sketch this because I said you sketch one by one. Next graph, you need to sketch this. E x plus 2 negative for x. This is same as this. Next graph. Same as this. So we now at this stage. Next one, you just put negative. So what kind of transformation? That's why you have to think what kind of transformation. I said before that when we put negative, what happened? Reflection, right? Then our graph will become this. E minus x plus 2, right? Like this. Right. Correct. Then is that we finish? No, because we still have 2. So we put two here. What happened when we put 2 here? Is that stretch vertically? Remember that graph, that's we call it transformation. It start from here, e to the power of x. Then go to the e to the power of x plus 2. This. Then go to the e to the power of x plus 2, negative. Then go to the 2 minus x plus 2. Then the last one will go to 2 minus x plus 2 plus 1. Minus x plus 2, same as 2 minus x. I hope that you did not confuse. Minus x plus 2, same as 2 minus x. I think this one, if you ask for the primary school, they know that. Minus x plus 2 is 2 plus 2 minus x. So it's like this, the process of transformation. We know where? This stage. Next stage, we have to put negative there. Next stage, we have to put 2 there. Next stage, we have to add with 1. Finish. Understand? So from here to here, we have transformation. From here, we have transformation. From here to here, we have transformation. Therefore, this kind of the example, we have all 4 transformations. 1, 2, 3, 4. Involve all of them. As we look at the example before, involve only 2. But now involve 2. The previous one involve 3. But now involve 4. You try. Because now at this stage, you're supposed to get this, the last one. Remember that when the process of transformation is like the process, I think in science, they say that the process of what they call evolutions. And we transform, and then get this. Same like COVID. Same. When the government announced that maybe by end of October, we will go to the what they call endemic. When the government announced, where? I think May or June, right? When the case grows very, very up. So some people, they're suspicious. Yes. But remember that in science, we say that that's the theory of evolution. Evolution is something that goes, maybe take long time. You cannot go to get the same. You cannot have what you do today, you want the result tomorrow. No. You ask for the people who achieve now. How they get the result, how they become like they now. And then they can just sleep and then tomorrow I become no. So seem like this. Look this. But at the end, we want this because there's another process. If you from the biological science, maybe you know that the words of evolutions, and you definitely know evolution is against revolutions. Revolution is something that go rapidly. Sorry. So we go for the transformation. Now we have to go to each stage, and if we look at what the stage before, looks like different, definitely because goes one by one. Right. This chapter 4. This is chapter 4. We have studied of the chapter of explanation and logarithmic function. And this chapter 4 question will be question on OBT later. OBT2. OBT1 you just finished. Next week we're going to have quiz 2. Quiz 2 for chapter 3. So it's alternate. You know that? Chapter 1, quiz 1. Chapter 2, OBT 1. Chapter 3, quiz 2. Chapter 4, OBT 2. Chapter 5, quiz 3. Chapter 6, OBT 3. Are we now in chapter 4 and we now in week number 8? If I'm not mistaken, we now in week number 8. So it's look like that you have to ready every time, because you get quiz, you also get after that you get OBT, open book test, and then you get quiz, and then by the end of the semester, after finish study, finish revision week, you sit for the end of semester examination, quiz, and also open book test, which you already did open book test 1 and quiz 1. We will calculate it. Everything is calculate here. So you cannot just wait until last minute. No, because tests come from time to time, and every test matter. Unlike school, right? Examination in school never count in examination for SPM, only count for examination of SPM, examinations of school just to test, but count nothing after that. Even though you score with the flying colors, count nothing. They will count the result of SPM. That's the what? the education systems of us. But in the university levels, no. They will count from day one. I remember that quiz next week will be night time as well. And quiz next week, questions will be one by one, but does not matter. You only need to submit of the last question. You submit all of them. Bear in mind. Because last time I found that many people who submit separately. Adam Arif, Adam Arif Faizil, and Adam Arif Syarul, Adnan, Adam Azrai, Adam Hakimi, Adam Harith, Ahmad Azib. The rest, I think, so far no problems. I hope that I will not encounter with more like that. You send it to me single file, which consists of all the numbers for the last questions. Put the answer there. Not separately. Not question one answer. No. Put all the answer, number 1, number 2, number 3, number 4, or if the question have number 5 as well, put in the last question, put the answer, submit in the last question. So it's going to be like that. Remember that quiz next week will be same like last week, night time, and also question will come one by one. And that talk about quiz. Currently, we in chapter 4. This chapter will be asked during during open book test. Next open book test. I think a week after quiz. But remember that when we study, early parts when we study of exponential functions is one-to-one function. Therefore, exponential function has an inverse. So later we're going to find we're going to do. At the moment, we don't know what is the inverse yet, right? So, any questions?
No, sir.
Okay. So I stop the sessions here today. Hopefully that you look back at this and you try to solve it. And inshallah, we'll see you back on Monday next week at 10 o'clock. Right. With that, I close the sessions today with Tasbih Kifarah and Surah Al-Asr.
Okay.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Welcome.